TTL Computer 2. Today we'll be taking a look at the physical design for our compact flash adapter card. And we're going to just get right on into this. And we are looking at the first sheet of our schematic for our compact flash card. And this is virtually identical to our simulation design, but I will call out the few differences as we go along. Okay, so again, we have a lot of this as our boilerplate. We have uh, our data bus buffer and driver chip. We have our control signals buffer chip, and we have our address bus buffer chip. And then we also have our 682 comparator that we use to do the address decoding. We have one extra logic chip that we use for our need for our write signal. And now we have the IDE header for our compact flash adapter card. And again, this is the pinout for a straight IDE 40 connector, and it's identical to what we saw in our simulator. Now, this is where we get into a difference from our simulator. Now, I mentioned that our soft start power supply was going to give us potentially a problem with our compact flash card, because the compact flash card can run in 3.3 and 5 volt operating levels, and it makes the determination which level to use based on the power that's applied to the compact card flash card at the time of power on. But with our soft start power supply, that's going to be less than 5 volts for 200 milliseconds. So to make sure that we are presenting a solid 5 volt source to the compact flash card, we need to do something special. And what we're going to do is we're going to reuse exactly the same circuit that we use for our soft start power supply. So we have a MOSFET transistor here that we're going to use as a power supply switch to supply the current to the compact flash card. And this will come up in an off state. And then after 500 milliseconds, this will bring the P-channel MOSFET low and will enable the current to flow to our compact flash. So in operation then, when the power is applied to TTL Computer 2, the soft start power supply for 200 milliseconds is going to be something less than 4 volts. PIC microcontroller will begin timing here, and at 500 milliseconds, so after the power supply switches to the full 5 volts, this will, again, bring the P-channel gate low and allow the MOSFET to drive power through to the compact flash card. And that will bring that, and that will have 500 milliseconds or more to fully start up before our reset signal allows the compact flash to run. Okay, so that is our active elements schematic for our flash card. Our passive elements, again, this is essentially boilerplate. We have our expansion card edge connector. We have 3 power decoupling capacitors, and then we have these bypass capacitors for one each for each of our active elements. And then we have our power lead indicator. Okay, so that's the schematics for our card. Now let's take a look at the printed circuit board. And this is it. And this is using the standard dimensions for all of our expansion cards. It's 200 by 150 millimeters. We see the card edge connector here. We have all of our buffer driver interface chips here. We have, this is the 33 ohm resistor network. Here's our buffer driver chip for our data bus. Here is our comparator to do the address decoding. and all those signals, the appropriate signals, are brought out to our IDE 40-pin header. And that's the header that our compact flash adapter card will be plugged into. Here we have our PIC microcontroller circuit with the MOSFET to delay supplying power to the compact flash card, again for 500 milliseconds. And then the compact flash card will plug in here, and there will be a right angle connector that we use for the compact flash card. So the compact flash card will be at a right angle here. And what this is this is a printed circuit board cutout. So that cutout will give room, will allow the compact flash card to, extend, into or beyond the edges of the PC board. Right, and this is just our power indicator light. Okay, so that's our design for the card. We can take a look at that in 3D now. And here's our card. And we can see now, it's a little bit easier to see what's going on here. But the compact flash adapter will have a right angle. This will actually be a right angle header. And the compact flash card will plug right in here. And we'll extend. The right angle will go here. And then the card is going to probably extend a little bit through the actual PC board. And it will protrude on the top, right above the top of the printed circuit board, probably up to about here. The card will go like that. Okay, so that's our printed circuit board in all its glory. And this has already been sent off to JLPCB for manufacturing, and we should be getting that back in a couple of days. Now, this was the first time I did a circuit board cutout, so we will have to wait and see that that comes back, in fact, cut out that way, and that the flash card will fit in there. But we'll see how that goes, but hopefully we'll get that right in the first time and don't have to do any kind of rework. Okay, so I think that's it for today. Until next time, thanks for watching.